Good morning, good afternoon, good evening, everybody. Depending on where you're joining from, I feel like it's obligatory to start every webinar with good morning, good afternoon, good evening. But again, regardless of where you're joining, we appreciate you. So what we're going to be talking about today is AI in the software supply chain and kind of the balance of building towards AI adoption while also instituting security safeguards within the software supply chain. So again, to introduce our panelists, you have myself. My name is Joe Coletta. I'm a product marketing lead here at ReversingLabs, and I'm joined by Vis Chirravuri, who is a software security technical director at Thales. I'm not going to speak for him. I'm going to let the gentleman speak for himself. Vis, do you want to just give a quick intro to the audience about who you are, what you do, and your expertise here?
Absolutely. Thank you, Joe, for having me here, and excited to meet new people all the time. So, good morning, everyone. Good afternoon, good evening, wherever you are. I have a very big name, Viswanath Srinivasan Chirravuri, and good luck in pronouncing that. But the good news, you can call me Vis in short, the first three letters of my first name, VIS. So anytime you want to have a question, anything, put it on the chat and just refer to me or to Joe as you want. I worked in cybersecurity for the past 20 plus years, mainly focused on software application security, software supply chain security, DevSecOps, cloud security. And recently, in the past 5+ years, I've been researching a lot on securing AI and machine learning as well. I'm a full-time employee at a company called Thales Group. I live in Austin, Texas, in US. I'm a project leader of an open source project as well called Secure Machine Learning, which I will probably briefly talk about later on. I'm a certifications guy, as you probably see on my background. I have over 35 certifications in cybersecurity and other things. If you're familiar with SANS and GIAC, I'm a GIC security expert, the GSC title. Um, I'm currently pursuing a Doctor of Engineering program at George Washington University. Some of you are probably familiar with that. It's a PhD program. And I have a master's degree in SANS Technology Institute. Probably some of you are familiar with SANS. I speak at conferences like RSA, OWASP, and DevSecOps. I'm an SME for CompTIA certifications like Security Plus, Cloud Plus. I'm a TA for SANS Institute, and I love tennis, by the way. So if you ever happen to be in Austin, come, let's have a good tennis match. See you around in a while.
Thank you, Viz. If you play tennis in the summer in Austin, you're a braver man than I. So props to
you. That's why it's Austin. It's always.
I can only imagine it's like a microwave on that tennis court. But yes, thank you for that intro. That was very, very insightful. Just to give you folks a quick background about who we are, ReversingLabs. We actually just celebrated our 15-year anniversary. And over those 15 years, we've continuously improved our solutions to become the trusted authority in both file software and file security solutions. So we have a threat repository of over 40 billion files of both malware and goodware. And that number continues to grow thanks to the good work that our threat research team methodically puts towards analyzing and categorizing new instances of malware and goodware files every day. Those files reach upwards up to over 40 billion files, and that repository puts us about 7 times larger than our closest competitor. So what people don't know is that our threat intelligence feed actually go towards feeding 60 of the leading cybersecurity companies that trust our data and give threat intel feeds to the solutions you might actually already be using within your environment. And we've received a few accolades that we're very proud of, including our highly rated channel partner program, along with being recognized by Gartner as a leading software supply chain security provider. And something that we're particularly proud of this year is actually being a direct contributor to the 2024 Verizon DBIR report. So to have our data published within probably what is the premier software research, security research paper of the year, that's something that we really like to gloat about. It's just a feather in our cap, and we're very proud of it. So that's in a nutshell who we are. And just to kind of get into the meat of what we're going to be talking about today. So our agenda is going to be broken up into 2 parts. The first part will kind of go into the facets of AI within the software supply chain. So that'll be divvied up into AI in the software that we build, AI in the software that we buy. So that includes commercial software products that might be powered by pre-trained AI models, and how AI is actually expediting software supply chain exploits out in the wild. And part two will be led by Vis, who will go into a securing machine learning framework, as well as introducing some data that, some research that he's been leading in terms of how AI can be weaponized in terms of data poisoning and propagating cybersecurity attacks by attacking the AI data and the AI model directly. So yeah, let's get right into it. So again, when we introducing the three facets of AI in the software supply chain, like I said, it's really digging up into three components. Again, AI for developers, so as in AI copilots that are being used to actually build the software that we run in our environments. AI powered products that either come in the form of software that is integrated with pre-trained AI models, or that may make some sort of API call to a publicly available large language model like ChatGPT. And again, AI-powered exploits in terms of how AI is actually expediting and is a force multiplier for known software supply chain attacks. So let's start into the first one, and that being how AI is being used in the software development lifecycle. So it's not a secret by now that AI is a boon for developers to build feature-rich applications at speed. And it should be noted that this presentation is by no way condemning the adoption of AI in application development. As a matter of fact, we know it's a force multiplier in terms of building, like I said, feature-rich application at speed. And matter of fact, at this point, it's probably safe to say that that ship has sailed at this point, as you can see from some of the stats we're showing on screen. 58% of businesses plan to use generative AI over the next 12 months to control or reduce software engineering costs. And that's a time savings from timeline slippage or code reviews and eliminating backlogs with the help of AI. So up to 50% of developer time saved when adopting low-code generative AI tools that, again, ultimately help developer productivity by eliminating backlogs, and 26% more tasks completed when using generative AI copilots. So again, this is really meant to be a value add for development in terms of building feature-rich applications that help move the needle in innovation. So, but with that adoption, let's see if my slide will proceed forward. Here we go. There are some challenges that come with, or some unknown risks that come with the AI adoption and software development. The first is really unknown training of the model that is being used as an AI assistant. So while a boon for developer productivity, AI-based developer assistants present some unknowns in terms of how those models were trained. So AI models are often trained on open source repositories, which may inadvertently include vulnerabilities or malicious code, or even introduce unknown ones into software that's being shipped, software that's ultimately being shipped. AI-generated code may lack sufficient security checks or validation, making it vulnerable to common attacks like SQL injection, cross-site scripting, or buffer overflow. The second is really a distance from the code. We're distancing ourselves from code and becoming generally less intimate with the code we develop. AI-generated code doesn't necessarily have the contextual knowledge of your organization's security policies, and thus can create a misalignment in regards to app-specific needs. So AI-generated code might lack robust testing, especially for kind of edge cases or security scenarios, leading to potentially missed vulnerabilities or malware examples. So again, code generated by AI may be trusted a little too readily, leading developers to skip critical steps. I'm not saying this as a generalization, but skipping critical steps in terms of code review, fuzzing, or static analysis. So again, a real-world example is adversaries intentionally injecting malicious or insecure code samples into open source data sets used to train the AI models, and then this can result in the AI unintentionally recommending insecure code patterns to production environments, which are then adopted by the developer, and then ultimately shipped to customers. So the third pillar is really kind of understanding understanding LLMs and AI copilots as a new attack surface. So The shift left movement has been a fixture in the security space for over a decade now, possibly more so. But with the rise of AI copilots, we now have something that's even further left than the developer, and that's the data training the model that produces the code. So what that does, what that creates in terms of challenges is unauthorized access to the AI model could allow insiders or attackers to manipulate its behavior, potentially skewing the code generation towards insecure practices. So without assurance of stringent access controls of who has access to the data, the training data for the AI model, attackers could potentially tamper with model settings or training data to influence the code that it produces. And the last thing I want to touch on is, again, a lack of visibility. So traditional code auditing and traceability practices may not be fully applicable to AI-generated code, making it harder to identify and trace vulnerabilities back to their sources. So this lack of accountability sort of makes it difficult to pinpoint the origin of insecure code or understand the decision process behind specific coding choices. So a principle to keep in mind is that the inherent trust model really doesn't hold water when it comes to AI-generated code. So it's not all gloom and doom, though. So there is an approach we can take to mitigate the proliferation of untested AI-generated code from causing problems downstream. And the analogy I want to use is consider the automotive industry and how it goes about conducting crash test safety on new vehicles. Vehicles undergo exhaustive crash testing from all angles of the fully assembled vehicle. So testing individual components would not give a clear indication of how the vehicle would fare in a real world accident. Excuse me. The same principle applies to software and illustrates why instituting what we've been calling sort of a final build exam that analyzes the entire assembled code, the entire assembled complete software package, and how that's so critical. So this would typically occur post-compilation, pre-deployment, when you account for all the build artifacts added during the CI/CD build process, which can amplify the size of the final software package by dozens of times over. So we're talking about artifacts that aren't included in the build manifest, and artifacts that aren't even that the developer may not be aware of as part of their as part of the assembled code. So, for example, malicious code can be embedded in a README file or embedded in an ML model or a machine learning model within the software package. So again, analyzing the entire software package in its final executable state, including every commercial, proprietary, open source components, whether they be human or AI generated, provides sort of that final build exam before releasing to production. So moving forward, let's talk about AI-powered products. So when I talk about AI-powered products, a lot of that has to do with commercial third-party products that maybe have AI embedded capabilities, or again, have some sort of external call to, so for example, an external API call to a large language model like ChatGPT. So again, the ship has sailed at this point, and it's really no question as to why adopting AI-powered products is a boon for businesses. Again, time and resource savings, productivity gains, new data insights. It's, you know, that ship has sailed once again in terms of why AI is a boon for modern businesses. But again, comes with some hidden risks, especially when we're talking about the use of pre-trained ML models within the software that we build and buy. So just to give you some quick context about what we're talking about, an ML model at a high level, a machine learning model is essentially a mathematical framework that learns patterns from a particular data set to make predictions and inform decisions. So whether you realize it or not, again, we use technology powered by some sort of machine learning algorithm almost every day. So item recommendations from Amazon, movie and TV recommendations from Netflix, so on and so forth. So in the context of software development, machine learning models are trained on large data sets to help automate decision-making processes and improve the efficiency and accuracy of various applications. So when we're talking about addressing ML, when we're talking about how that can be a vehicle for malware within machine learning models, training the machine learning model itself is an expensive product. It requires large data sets, immense computing power, and significant time. But to save resources, companies and researchers often share their pre-trained models on platforms like Hugging Face or TensorFlow so that others can reuse these third-party models without having to retrain from scratch. So this is where serialization, a process called serialization and deserialization comes into play in terms of how these are integrated and how machine learning models are integrated into the final software package. So real quick, serialization is essentially the process of converting a trained model into a file format, like a pickle file, for example, that can be saved, shared, or stored for a later use. So deserialization is the reverse process, where the file is loaded back into memory so that the model can be used again. So this allows teams to either to share ML models across projects or organizations, essentially accelerating development of an AI application. So the caveat is this: serialized file, like pickle files, which again can be embedded within commercial software applications, third-party commercial applications, can contain more than just instructions when they're during this deserialization process. They might also contain hidden code that can run when the deserialization process kicks off. So this is why it's dangerous to load serialized files without checking them first. So untested ML models can carry malware payloads that can execute code as soon as the model loads. So access system interfaces like connected hardware like webcams, for example, make unauthorized network connections to send data back to the attacker, or manipulate other pickle files, among other things. So there is a process that you can take in terms of adopting. There is a process as a software producer. As a software producer, there's steps you can take to ensure the safe adoption of pre-trained ML models. So when downloading from a third-party repository like a Hugging Face, like a TensorFlow, models should be assessed and analyzed before the experimentation. So namely, before injecting the model with any sensitive internal training data to train the model further still to fit your use case. And also, once again, before development, once the model is fully integrated into the software package. And again, I'll allude back to my car crash testing analogy just from a moment ago. So those are kind of the two core fundamental phases you can take. And there is a shameless plug in here. I do apologize, but our software supply chain solution, Spectre Assure, does have the capability to assess ML models like pickle files to assess for any sort of malware embedded within those files. So again, this is sort of a process flow using a tool like Spectre Assure to assess a pre-trained ML model before experimentation and just prior to deployment. So a similar principle applies to commercial third party, and sort of applying this to a third party risk management use case. So we're no longer talking about the software we build, but talking about the software we buy and eventually deploy to our IT environment. So when purchasing software with embedded AI capabilities, there are a few key factors to consider. One, what kind of data is it? What kind of data is the application handling? Where is the application being deployed? And does the software make any sort of API calls to external LLM services like a ChatGPT, for example? So this is sort of a quick process flow to kind of illustrate the notion of how to make educated risk decisions throughout the software consumption lifecycle, from acquisition, maintaining the application once deployed, all the way through deployment. So we built a repeatable framework to help operationalize AI security in the context of third-party software risk management. So this slide is really meant to serve as a starting point to kind of begin that internal discussion of how your team can use a tool like Spectre Assure, for example. Again, shameless plug, I do apologize, to analyze, again, commercial packages as part of the buying process, and how to communicate those findings both to internally within your team, like for example, for your IT operations team, for your SOC team to establish mitigating controls, or to auditors, and even to the vendors themselves to communicate the risks communicate the risk, which can then actually be expedited if you have any sort of contract language that actually says that certain security vulnerabilities have to be patched as part of your purchasing agreement. So again, this is just meant to kind of serve as a quick, sort of a high-level framework about how you can sort of safely adopt and deploy AI-powered software. Okay. All right. And the last component I want to talk about before we move forward is how AI is used as sort of a force multiplier in terms of automating a software supply chain risk. So when this is not necessarily going into attacks targeting AI directly. We'll actually let Vis actually dig into that a little bit more with his research. This is more talking about how AI is sort of a tool of the attacker in terms of propagating software supply chain attacks. And they really kind of come out into four categories: is automation, up-leveling sophistication, hallucinations, which is an interesting one, and obfuscation. So automating vulnerability discovery is what I'm talking about. Threat actors can actually use AI to more quickly identify and exploit vulnerabilities in widely used software packages and libraries. By scanning large volumes of code, AI can actually rapidly identify zero-day vulnerabilities or weaknesses in common dependencies or libraries, enabling faster and more targeted attacks. And when we're talking about sophistication, really what that comes down to is AI-powered tools used to help attackers identify optimal points in the code base for injecting malicious code that's hard to detect. So this actually kind of manifests in the form of obfuscated or polymorphic code polymorphic malware packages. It actually changes with each attack, making it harder to detect for traditional antivirus or sandbox tools. This is a capability that was thought to be really kind of siloed to more nation state sponsored attackers, but because again this is so readily available to attackers, it's becoming much more commonplace, and we actually have some examples of that out in the wild. The third one is hallucinations, and this was an interesting one. It's actually something that's been reported by in the Register, if you want to look that up. What hallucinations comes down to is, excuse me. So AI hallucinations, again, falsehoods or inaccuracies that are a result of generative AI model output. So again, what we were talking about was a lot of big businesses and enterprise have actually published source code that incorporates a software package previously hallucinated by generative AI. So not only that, but someone having spotted this reoccurring hallucination, like an attacker, for example, had turned that made-up dependency into a real one, which was subsequently downloaded and installed thousands of times by developers as a result of AI's bad advice. So essentially, an attacker is essentially almost like a form of typo squatting, where they're actually creating malware under the guise of a AI hallucinated software library, for example, and using that as a guise to distribute malware to businesses. So the end result is, again, a developer would inadvertently download malware, assuming it's legitimate as a recommendation from an AI copilot tool, for example. And last but not least is obfuscation, which is really kind of just the use of AI to introduce layers of obfuscation and encryption to allow previously known malware to bypass detection techniques. So really what this comes down to is that essentially coming down to fighting fire with fire. So the vast majority of modern security companies use machine learning models to accelerate processes in learning, automate defenses across the network, application, and cloud infrastructure. So these machine learning powered classification systems are an essential component in terms of battling AI fueled threats. So in order to identify in the context of identifying undocumented novel malware, be it AI generated or not, requires a level of analysis that looks at specific threat indicators to determine whether that code is actually malicious. So a prime example of these types of techniques is a concept known as explainable machine learning. And in a nutshell, explainable machine learning is a technology that converts objects to human readable indicators describing the intent of the code found within those objects. So for example, in the case of malware, for example, our Spectre Search solution, which has these explainable machine learning capabilities embedded in its malware detection engine, will in human readable terms outline threat indicators such as whether the code can read, write, encrypt files, or iterate certain disk drives, for example. So in a nutshell, machine learning techniques are a great choice as a first line of defense. And in terms of identifying signatureless systems, signatureless malware indicators. So these kind of systems do a great job of identifying whether something is malware or not, and even to identify what type of malware it could be. So the detection outcomes are predictive, not reactive. And that makes detecting new malware variants or tampering indicators that much more possible. All right. So with that being said, I'm going to turn it over to Vis, who will kind of go over a broad stroke overview of some of the research he's conducted in terms of how machine learning and AI models can be attacked directly, as well as a framework that he's developed as part of his research. So Vis, I'm going to let you take it from here. And if you need me to proceed the slides, just tell me to do so, and I will do so, whatever you say.
Thank you so much, Joe. That was awesome. So, like, in a nutshell, if you see what exactly Joe mentioned, the AI for developers, AI powered products, or the AI exploits, all of this. The next slide, please. Where if you think AI is, and I want to start with a question to you all in the audience. When you talk about implementing AI in any of the use cases that you can think of, like a chatbot or anything, what are the threats that come to your mind? And the first question is like, okay, do I have any threats when I implement AI? So what I always see for an answer to this question is only in the two big categories, and I call them malware ML. And I'm not talking from a full AI perspective, and I'm confining myself to more machine learning, because you can do a lot of rule-based things with AI, which is beyond the scope. We will talk about the data sets and models and everything that exists. So let's talk about machine learning. So from going on further slides, we will specifically talk about machine learning. So threats to machine learning, I see them as two main categories called malware machine learning and the adversarial machine learning. And what's the big difference between the two? And that is exactly what Joe pointed out in all the previous slides, where he's talking about the malware aspect of machine learning, which means you have a data set that you can download from various websites, or you have a pre-trained model that you download. Attackers can use these as a medium to send their payloads of attacks into your company's network or into your home network, anything. So the word malware, if it comes, what exactly is that? It could be a virus, a Trojan, a spyware, an adware, so I can push ads to you, or I can do lots of worms and many other, all of things together we just call as one word malware, which is bad, in English. So if you put any of the malware that I mentioned into a data set, into a model, and spread it through the company, I am not attacking AI, but I am attacking the assets that you have in your organization through the use of machine learning assets, which are data sets and models. I'm spreading malware into your company because of the supply chain of your data sets and models that you're using. So that's the first part, which Joe has covered a major portion. And I want to talk about the second half, which is the adversarial aspect of machine learning, where the goal is to not attack your assets that you have in your company, but attack the machine learning itself. That means if you ask a question to a machine learning model like GPT or PaLM2 or anything like BART, where you ask a question, what is the capital of France? We all know it's Paris through our knowledge, but it should probably, if it answers like Washington, DC, which is the capital of US, that's a problem. So an adversarial machine learning where is we are attacking the machine learning model to make a wrong prediction, for example. That's one of the attacks. So like that, if my goal is to attack, break the functionality of the data sets, break the functionality of the training, break the functionality of the predictions it makes, that's adversarial ML, right? So my framework, and I developed it as part of the experts in my company called Thales Group, and that's where I want to talk about briefly, completely vendor neutral. So you will see how we are talking about. So next slide, please. As IBM points out this, and I love this slide, this picture from the IBM's tool called ART, the Adversarial Robustness Toolkit. There are so many attacks you can think of when you're attacking machine learning, but they nicely categorize this into 4 things, which means the poisoning. Poisoning means anything, the data that you have. Oh, I lost the slides, Joe. At least I cannot see. I don't know about the audience, but
Nope, I'll bring those back up. My apologies.
cheers. No worries. Yeah, talking about poisoning as the slides come up. So for example, you have a bunch of images that you have a data sets. An image can be a simple picture with a number like 7, like for example, or number 8, number 9, and you want the model to identify what's in the picture, which is exactly how, for example, an autonomous car like Tesla and everything works. So they see the surroundings, they identify the objects, and that's how it's able to drive autonomously, right? So it identifies the object in the picture. So if I just put number 7 in a picture and I give to my model and I want it to identify as 7, but if I attack this model and it makes a prediction as 8, I did something change on the model. That means I'm trying to poison the data sets here. So as an speak about this, these attacks like poisoning the data sets and inference and attack is, in simple terms, inference is if I'm able to get what data was used to train the machine learning model as by asking a question. As for example, I will say, I'll pick one of your name if it's okay from the audience, like Craig. What did Craig do yesterday? And I asked this question to ChatGPT. Obviously, it does not know because it's a private information related to Craig, and probably he didn't give that information at all to ChatGPT. So I ask a lot and lot of questions to ChatGPT or other models, and I want to know what kind of data set was used to train the models. Then I'm able to infer what what data was used to train the model. For example, right? That's inference. Or extraction is understanding the parameters of the model, the weights, the multiplying factors that are used, which in the math numbers or the hyperparameters and everything that I'm able to extract by reverse computing the math algorithm. That's extraction from the model. That is the intellectual property of a model. We are able to extract it. And I'm just checking here for a second. Did we completely lose my hosts here? Joe, are you still in the call?
I am here, yes.
Okay, fine. Thank you. I was like lost there. Okay. How was I speaking? Yes, extraction. So we are able to get the weights and parameters by reverse computing the math on that what was used. So if I ask a question, what's the capital of France, and it says Paris, or it says the capital of France is Paris, and it gives you a statement, I can start reverse engineering what is the embeddings behind this, what is the math numbers behind this, what kind of algorithm was probably computed on the back side, and I can start reversing slowly all the weights, all the parameters, all the biases information that was there in the machine learning model. That's extraction attack. These are all the things that really happened recently. In December 2023, there was a TikTok user who was able to download the entire weights of an OpenAI's GPT algorithm as well. They were real life attacks that really happened. You're able to extract, and if you extract all the weights, you can rebuild the model, build a competitor tool completely, right? So evasion, the other attack, is where I make the model do a wrong prediction. That means you send a photo of a dog on the road, an autonomous car is going on, and there was a dog that was passing through the road. The picture of the dog was probably read as an elephant, or it was read as nothing. It was just a tire on the road or something. So you can misclassify. You can make the model misclassify it completely. So that's evasion. You're like bypassing all the controls on the model and making it do something completely wrong, right? That's evasion. Uh, so in these, I don't want to go into all of these in detail for you, but just one slide I want to take a minute and show you. For example, you take a picture, which I told you, like a number 7, okay? And how would I really attack this? How would I poison this in the supply chain? So if I use an open source model, we all know like there are so many Mistral models or GPT models. Many things are open source on the Hugging Face, right? You all know Hugging Face is like the GitHub of the software, where all the customized models exist, the data sets exist, which you can freely use it and you can explore them as well. So imagine I'm using an open source model and I want to explain the risks behind this. And I hope a lot of industries are using models because they're open source. They can't build from scratch. It's expensive for them. And I understand it's expensive to build a model right from scratch because you need lots of computing power and everything. But imagine you have an open source model that sits there, and I'm an attacker. This is an attacker. He knows that if I send the picture of 7, the prediction is 7. You can see this. The model is absolutely working fine. Now I make a small perturbation. Perturbation means a small change that is not physically seen by human, but from a system point of view, it's a change. So I add like a small pixel level change that I do it, a gray as white. Everything at the end, it's all math, right? If you have a full white cell, it's white, it's like number 1. If you have a gray color, it's something between 0 and 1. If it's black, it's 0. That's how the math operates in the machine learning on the back end. So if you start making a pixel level changes, so I made a small, which is called epsilon, which is the amount of change I can do on the picture. If I make an epsilon is 0.025, a small change, this prediction is still 7. So I keep increasing the epsilon value, then that means the amount of change I make on the picture. And at certain epsilon value, the minimum epsilon value, now the prediction became 3, it's no more 7. So why is this information useful to me as an attacker? Now I know what is the minimum amount of change I have to make on the input that will make a wrong prediction by the model. Now, because you guys are using an open source models, now that epsilon for that model, as an attacker, I know it. So if you put a question and that question can be tweaked in that with that epsilon value, or the change that I can create and a perturbation I can create into the input, that will start misclassifying, and it's no more 7. You start see the last 3 ones are like prediction became 3 now. It's not a 7. But you might argue saying that, hey, that even humans can see there is a significant change. Yes, I wanted to show you the physical change, and that's why I was showing you there. But the aspect is you can do change in a way that humans cannot detect that, but for computer, it's a different prediction now. That is where attackers are trying to understand the minimum level of perturbation and disturbance I can create in the input, which will make the model misclassify or make a wrong prediction. That is evasion attack. So these are easily understood on the open source models that you use. And I'm not telling you to make all commercial your own internal tools because it's expensive, and I understand. But I want to highlight the risk that yes, there is a risk that attackers can download these models. They can evaluate these models to understand at what epsilon, at what perturbation change, the models start breaking it. So that's the point behind this slide. Next. And I try to make a research on this over the years, and I'm just putting a summary of the research here, not to give you more technical details here. That if I put these evasion, extraction, and inference, and the poisoning attacks from a risk point of view, and of course, risk is so subjective to the amount of asset sensitivity or the likelihood of the attack that you're performing, and many things. I'm not talking on all of that. I'm just trying to average all of this and put you in general. I have to generalize something to be able to put to you. Yes, you do have a higher risk of using open source or a model that is publicly available, but still closed source. You know what exactly is a source behind a model? It's not the source code, it's the weights. So normally when you put all the weights and parameters and you make it completely open, that's open source. So that's actually the source behind it. And that's sometimes we have various use cases like RAG, retrieval augmented generation, or LoRa, the low ranking adaptation. People have different ways of using open source models or the closed source models. They are publicly available for free. We can just take them. In RAG, you just put your own data. You're not training the model, but you're taking a contextual data and answering certain things. Or in LoRa, you slightly change the ranking of the weights based on pre-trained model. I take a pre-trained model, I give my pictures to it and slightly change the weights, which means low rank adaptation, LoRa, and I get the answer. So either in LoRa or in RAG, the point that you see is you are using an open source or something that is publicly available model. People know the level of alteration to make to the input, if I have to say an alteration or a perturbation technically, that they can bypass it. So I want to highlight that risks exist for these. Of course, the risk is pretty low. It's not impossible, but it's pretty low if it's a completely proprietary model, because I do not know the epsilon value at which the model will start breaking it, right? If it's your own model, which you built it, but of course it's expensive. Security and costs are like inversely proportional. So if you try to make your own model, it's super expensive, but of course it's good in security point of view, right? So and vice versa. But you get the point that I'm trying to say here. And yes, there are lots of other vulnerabilities which OWASP top 10 for machine learning and even for LLM, the OWASP has made. Even for 2024, by the way, the list has been updated recently, last month for 2024, 2025 and beyond. There are new um, uh, vulnerabilities that has been highlighted as well. So, and that the point that they are trying to highlight here is the supply chain vulnerabilities are an important aspect. And because not every company can afford to have their own models, their own data sets being built and easily like that. So they are taking pre-trained models from Hugging Face and doing it. You just have to be aware of that. So what we did is we built a framework, just like Google SAIF, Secure AI frameworks, and many other companies have come up with their own frameworks. For Thales, we did our own framework as well, which is open source. There's nothing commercial behind this. You're free to go into that GitHub repository link that I just put there at the end and have a look at it. There's tons of information out there what exactly you need to do if you are implementing an AI use case for anything, especially in the future. In 2025, I can tell you, after I hear the talks of Sam Altman of the OpenAI or the CEOs of Google and Microsoft, or even many big people talking about AI agents, right? AI agents is the new evolution in 2025, and I don't use the word AI agents. Honestly, I call it a software robot. A software robot. I just use it. Uh, the simple example is, till now you have used AI as a chat model where I put a question, I get an answer, which is kind of prediction, technically speaking, not an answer, it's a prediction. It gives you an answer, but it doesn't limit to that. An agent or a software robot, as I personally call it, is like something that can do a task. So, for example, not just writing a code with Copilot, but can deploy the application into a web server and host a website by reconfiguring a DNS server, which is a task or a mini project for you want. So these are AI agents, and they will rapidly grow in 2025. And that's the trend I'm seeing a lot right now, which I call it as a software robot. You will see a significant amount of software robots growing in, and people will heavily rely on open source models or these models from the Hugging Face. So risks, the attack surface will grow a lot in the 2025 year, and you will see why these kind of frameworks are significantly important. You have to focus on all the 5 elements of data, which is data that you bring in either as a pictures or as a lot of text from your Confluence, Jira, or whatever places that you bring in the data. The model security, the underlying platform, how you expose it as a web application or a web service through REST APIs, the compliance aspect, the privacy and security compliance aspect, and the human element as well, which means educating your own developers. Especially, I see the survey where a lot of you are security people, so which means you need to train your own developers on these kind of risks like evasion attacks, poisoning attacks, inference attacks, extraction attacks, and all of this can happen through the supply chain aspect. So you or the denial of service and everything. And rightly pointed out by Joe, the kind of serialization, deserialization that you see is exactly where I've seen a lot of command injection happening. I download a pre-trained model from Hugging Face, and the moment I load it into my workstation, there was a command injection that was happening to read my Linux information and then posting it to the attacker through a command and control servers. Malware and adversarial have become a bigger concern as well, but that is not stopping the technological evolution out there. People are exploring in AI agents and software robots. So 2025, you have to be more and more concerned, in my opinion. And as I hear the experts talking in the industry as well, there is more and more concern about cybersecurity and risks like these. Okay, just I don't want to go into the detail of the framework. I know we are running out of time. So I just want to point out that when you think about data security or model security or platform and compliance aspects, you have to think from two perspectives. Security is cost. I know it's money, so you have to balance it in the right way. So what are the goals behind these? You have to think why I have to consider data security or model security or platform. What's in it for me, and how do I convince my management or my customer when I have to think of security? So that's your goal, and the techniques are how you do it, an implementation way. So beyond each technique that I point here, there is a huge number of security activities and the associated guidelines and the associated security tools in the framework of this repository. So I encourage you, go there, look out that open source information that I put there. There are also slides which I've spoken at different OAS conferences, which I made it open source, and many other content of great companies like ReversingLabs and many other companies' documents that I put there. So look at those, take advantage of those open source information. So that's it. Over to you, Joe.
Thank you, Viz. And I am back live on camera. I apologize, folks, for any technical difficulties. Real quick, let's just open up to a couple questions. We did get one live from the audience. Question from the audience. I don't understand why proprietary models is facing medium risk from extraction risk. So I think, Viz, that's relating to your framework from a previous slide. I don't understand why proprietary model is facing medium risk from extraction risk. Is it due to internal human risk?
Good question too. I love that question that you asked me there. You know, when it comes to AI versus the traditional software, we should not probably call it open source and closed source. We should call it open box and closed box. And these terms have come, we call the box as the model, honestly. In the open box and closed box models of machine learning, in a proprietary models, you need access at least through an API or at least through a way to communicate with the model to be able to understand it. In proprietary models, what I meant was more where in order to extract the weights, I need an API access, and I need to understand this. Today, GPT is open source, or Mistral is open source. We know these. We have an easy way of getting access to it. Rather, I should say, a proprietary model is where I built a model dedicated to a customer or a purpose that I want, which is not easily accessible by anybody beyond my. So it's a closed box, completely owned for a specific purpose. That's where the risk is completely medium, and yes, human element as well. And I deployed a model in my own company, and we have been seeing people can put customized data and everything. People start exploring accidentally. It was probably not intentional, and they do that accidentally, discovering, hey, we see that I think you didn't train your information with this because I asked certain question and it didn't come up. People can make inference-based, extraction-based kind of queries accidentally, unknowingly, and this does happen. That's why I kind of put it medium, subject to debate, depends on, again, the confidence of the data and the way you have got access to it. But if I have to generalize it, I categorize data as medium. And I hope I answered the question.
Sure. I think we have time for one more question. What are some privacy considerations when adopting ML models?
Okay. So an amazing question. I love that people talk about privacy. When you talk about privacy, privacy is an enemy to machine learning and AI. And that's how I always say it. The more people say, I don't want to give my data, it's my own data, or I don't want to tell you what I'm doing, then AI will fail. Honestly, AI will fail. If, for example, if you don't tell Google Maps your own interests or your own point from where you're going from one place to the other, Google Maps will not be able to tell you, hey, there's a Starbucks just like 2 miles ahead. I think it's time for your coffee now. It won't be able to tell you that. So AI will fail if you don't give the data, right? So privacy is a bigger aspect of this. And to handle privacy, honestly, there are 5 different architectures. If you and I want to briefly talk about 5 different architectures if we have the time here. I'll just take a minute. For example, if I talk about federated learning, federated learning is where I want to build a model like GPT, but I cannot take the data from Wikipedia or all the internet sources and everything, right? So I just want I want your data, but I cannot just take your data without your permission and just use it. So what I can do is I can give the model to you and ask you, can you please train the model with your own data? Don't tell me what's your data. Just train the model. And I take the model, give to Joe, and ask Joe, can you please update this model with your data? Then I get the model. I train the model again with my data, and the model goes to different places. So, and finally, we get a final model. I didn't access any of your data, but the model is trained and understands. So there's a little bit of privacy handled there. So that's one scenario. The other famous, although I don't want to cover all the 5 aspects, but the other famous privacy related thing is homomorphic encryption. It's called HE. In fully homomorphic encryption, it's hard to pronounce for me, fully homomorphic encryption, uh, people ask the question in an encrypted way. As you can think like that. Zama is one great company that I've been researching a lot on this, where the model is trained on encrypted data. It doesn't know the clear text data. The question is coming on encrypted. The answer is encrypted. You decrypt and you will see the answer. So which means information is limited only to you. So that's homomorphic encryption designed for privacy. So some of these architectural approaches exist. Or one last thing I can tell you is also called uh, what do you call this? Synthetic data. Synthetic data is the data that AI generated. So for example, I want a bunch of Donald Trump pictures. I cannot go to Donald Trump and ask him because it's a privacy concern. So what I'll do is I'll ask AI, can you generate me 100 pictures of Donald Trump to me? And it generated that synthetic data. So if I use the data generated by AI for my model, probably it's a gray area in the privacy legal aspect. The bigger risk in privacy is legal most often. So I am probably taking care of the privacy aspect. So there are approaches like this, either FE, fully homomorphic encryption, or federated learning, or synthetic data. There are architectures that people can take care of, that they can use it to handle the privacy.
Awesome. All right. We are at the top of the hours, folks. So again, thank you all for the questions that were submitted. If whoever's sharing, if you could just proceed to the next slide, please. Just want to give a quick teaser at.
Oops. Okay. I was sharing it and I'll share it back again.
Perfect. All right. So yeah, just a quick sentiment before we sign off for today. Again, thank you, Vis, again for sharing the research and the insights that you bring to the table here. We do appreciate it. Just want to give a quick teaser about some other virtual events that we do have coming up at Reversing Labs. Next week we have a doubleheader. So we have a couple of my colleagues will be talking about RL's proprietary high-speed recursive binary analysis engine and dynamic analysis capabilities. Within the context of traditional sandboxes, or how that compares to traditional sandboxes, followed by another webinar, and I'm actually really excited about this one. Our chief trust officer will be joined by David Hirsch, who's a former SEC enforcement agent, who will dive into the latest SEC actions around software transparency and how that's sort of manifesting out in the wild in terms of both business liability and personal liability to security executives. And then before we head out for the holidays, we'll hear from Forrester analyst Ala Valente. This one will be available on demand. Excuse me, this one will not be available. This one will not be available on demand. So if you do want to join, be sure to attend live and share the link with your friends and colleagues. And we will not sure if we have the registration link. Actually, we'll post that in the chat very quickly. So if you're interested in the webinar with Forrester, that's the link to register. But yeah, thank you very much, everyone, for joining. That's the wrap for today's presentation. We appreciate your time, and again, thank you, Vis, for joining us today. And apologies for any technical difficulties. So with that, have a great day, everybody. Have a great rest of the week, and enjoy your holidays. Take care now.